This is the first video in a two-part tutorial series where I show you how to create a movie in MATLAB and then bring that into Blender for rendering. This is the first video, so I'm focusing on the MATLAB portion, how we're going to export that field animation from MATLAB. And you're looking at the animation that we're going to export. So it's the fields that would be around an electromagnetic cloak. This is really meant to replace whatever simulation you might be coding in MATLAB. That could be finite difference time domain, finite difference frequency domain, beam propagation method, plane wave expansion method, whatever it is, somehow you're going to calculate a complex field and you want to animate that. So I know this tutorial is not about the MATLAB code creating this field, but I will briefly step you through that, but then we'll take our time when it comes to exporting the movie. So in this code, we will initialize MATLAB. We're then opening the figure window that comes up centered here. Then we enter the dashboard where we have all of the hard-coded numbers and we're controlling everything about this computer program. So our cloak, the inner part of that cloak where the object will be hidden, has a radius of 1. The cloak itself will have a radius of 2. The wavelength will be 0.35. Why did I choose that? Well, I played with this for a little bit and I just thought that looked best. Now the grid over which we're calculating that field should be larger than the cloak. So if the cloak itself has a radius of 2, it would have a diameter of 4. So I am making the physical width of the grid 5. And I'm making it a square grid and I'm making it 1024 by 1024 pixels. In this next part, we're calculating the complex field. So I'm calculating a grid, a mesh grid that's 1024 by 1024 pixels, consistent with what I had up in the dashboard. The magic for this cloak happens here, and I talk a lot about this in other videos, but here's the short answer. So I have this Cartesian mesh grid, and this might be how you're intuitively picturing a grid. The first thing I do is convert that to polar coordinates, so theta and radius. I then do the coordinate transform that maps the cloak from the ordinary coordinates to the transform coordinates. Now, once I have that, that is really, it's moving all of the points on that grid. I really only want to move those points within the cloak. So for all the points outside the cloak, I am grabbing the original coordinates. So once I have this new radius function that transforms the coordinates, I go back to x, y. Now at this point, I can kind of forget that there's a coordinate transform that's been done in there. I'll calculate the wave as if there's not, but when I draw it, I can see that there's a cloak. So first I calculate the wave number, 2 pi over wavelength. I then calculate the wave going in the x direction, but of course this is not the original x from the mesh grid. This has undergone a coordinate transform, so it actually has the fields avoiding that radius of 1 in the middle. Now it will calculate fields in the middle, which doesn't make any sense, so I just set all of the fields within that first radius equal to 0. I then draw the fields. And notice I'm drawing the real part of this field because f is a complex number, and it's supposed to represent the output of a simulation. So if I go ahead and run this, I see what I've just talked you through. Now don't worry about if you didn't follow everything, because all of this code, really you would have your simulation, and what I'm typing now would fall after that. So let's go ahead and do that and now focus on the movie part. So I like to start in the dashboard, and I like to add a feature so that I can turn the movie making on and off. And if I have it off, I can now test my code, I can get things looking right without having to render a movie each time. And when I think it looks good and I'm ready, I'll turn it on and create the movie. So this next section in our dashboard, we will call movie parameters. And this first parameter is the ability to turn it on and off. So I'm going to say make movies, and notice that's plural, meaning more than one, and I'll explain that in a second. And I'll set that to 0, meaning don't make any movies. That way I can test the code. So the reason I'm calling this movies is that we're actually going to export 2 movies. One is going to have color information, which will indicate the positive or negative parts of the wave. The other will indicate the amplitude portions. And why am I doing it that way? Because I've played with this, doing this a bunch of different ways, bringing movies in the MATLAB, and this ends up looking the best. I used to just pour in a single movie, but then I'd have to try to make certain parts of that field transparent. I never got it completely transparent, and now I'm seeing like black, colored black part of the wavefront being non-transparent. It was just ugly. So what I'm showing you is the latest and greatest in terms of how I like to do this. So we have two movies. We need to name both of them. So movie name, and I'll call this with underscore COL for color. So this will be the name of the movie that conveys color. And I'll call this EMWaves underscore COL dot MP4 because we're going to create MP4s. I really like that. And I don't like to retype, so why don't I just copy and paste that line. I will change COL to AMP. So this is the movie that's going to convey amplitude information. And then I change the name of the file with an AMP in there. Okay, got the two names. The only other parameter that we really need now is the number of frames in this movie. And this is something I'm going to want to remember when I go into Blender. So 50 frames. We have a complex field, and anywhere from like 40 to 60 frames, if that is put on repeat, that looks really nice. I think that's a really good speed for a wave. Of course, if you want to slow it down, make it 80 or 100 frames. If you want to speed it up, 10 or 20. But I think 50 looks pretty good. Okay, so the next section of code, what we want to do is open the movies, create those files internal to memory. We want to set the quality to 100 because we don't need any compression. These are going to be relatively small movies with only 50 frames. So why have any compression? And then we'll go ahead and open those movies so they're ready to be written. So I'll start off if make movies. So only if we have the option turned on to make the movies will I actually open them up so we can start adding frames. Otherwise, they will not be opened. So create a handle to the movie, an object handle. We will use the command video writer. And we'll give it two input arguments. The first one is the movie name. And we'll give this the movie name of the color movie. And what type of video is it? It's an MPEG 4. So that's how we select the compression. All right, now we want to select the quality. We could also do frame rate and some other things. Frame rate isn't so important because when we bring that into Blender, it just gets overwritten with whatever the frame rate is inside of Blender. So vidobj dot quality equals 100. So there's going to be no compression on this. And then we'll go ahead and we'll open this video for adding frames to it. Underscore COL. Okay, I don't like to retype stuff, so I'm going to copy and paste that because we have to do the exact same thing, but for the movie that's going to convey amplitude. And this should not just be video OBJ, it should be video OBJ underscore color or COL. Sorry, I forgot that, and I did not forget that here, because the second one will be underscore amp to convey amplitude. And then, of course, the movie name, amp. And we won't know if we made any typos here until we actually turn on the movie making and it runs this section of code. But that should open both movies so we can add frames to them. At this point, we want to scroll down to the bottom. So this was the section of code that drew the picture we were looking at here, but we'll close that. We're not really interested anymore. I won't delete the code, but we're going to create a new section where we make the movie. So I'll go ahead and copy and paste this section header. And I'll name this something like Make Movies. But of course, it will only do that if we've requested it to add frames. So we have two movies. and one will convey color, the other will convey amplitude. We're going to want to make a custom color map for the one that is conveying color. So the simplest thing, and it still looks really good in Blender, is just a simple binary color map that has two colors, one for negative fields and one for positive fields. So color map, we'll choose the two colors here. So there's a red, green, and blue component. So 1152.84, and we'll divide that by 255. So that is a blue color consistent with the EMPossible colors. And these numbers really need to be between 0 and 1. For some reason, I have them memorized on the 255 scale, so I'm just dividing by 255 to get them to be 0 to 1. The second color, which is the green color for the positive part of the wavefront, will be 10.165.74, and we will also divide by 255. Now the color map is going to contain both of those at the same time. So C1 over top of C2. So I can, if I ran this, I could check if I made any mistakes anywhere. Okay, MATLAB did not yell at me, and I can look at my color map and I can see both of my colors. Okay, no mistakes yet. Let's go ahead and now create the loop that will add these frames to the movie. Add, whoops, I spelled add wrong. Add frames to movie. So we're going to set up a loop for n frame equals 1 to big N frames. And the big N frames is what up in the dashboard we set to 50. So this little n frame inside the loop will go 1, 2, 3, 4, 5, all the way up to 50. We have a complex field. What we want to do is add a little bit of phase every iteration so that all 50 frames we can watch this wave move. If we draw the same field each time, it's not going to move. So we need to calculate the phase for each frame. So this step will be called calculate next phase. We'll call it phase. The first thing I'll do is I'll calculate an n frame. So that's the number that's going 1, 2, 3, 4, 5, all the way up to 50, divided by big N frames. Well, if this is going 1 to 50 and then we divide by 50, this is going to count from a number close to 0 but not 0 all the way up to 1. Well, we want the phase to go essentially from 0 to 2 pi. So if I say 2 pi times that, now my phase is essentially going from 0 to 2 pi, but there's something very fancy happening here. We're not going from 0 to 2 pi. We're going from something very close to 0 but not quite 0 up to 2 pi. Because if it started at 0 and ended at 2 pi, we would have two frames with the exact same field, and every time the animation would loop, you'd see this quick little glitch. This will make it look smooth and continuous. So now that we know the next phase, we need to add that to the field that we calculated. So the field is F. So let's go ahead and calculate next field. So this will be the field F, but with the phase we just calculated added into it. So we'll call it Fi, so F for this iteration. Fi is the complex F that we calculated above that would be the output of a simulation times exp 1i times phase. Now, I'm assuming the output of the simulation was something that was done in the passive sign convention. So a wave traveling in the positive z direction will be e to the minus jkz, in which case I add phase with a positive 1i. If for some reason your wave appears to be going backwards, that's because you calculated the wave in the positive sign convention. Just put a negative here, and you don't even have to worry about figuring it out. If your wave's going backwards, just swap the sign here. Not a problem at all. Okay. Draw field color. We'll use P color instead of image SC because it looks a little bit smoother. So XA, YA, and we're just going to draw the real part of FI. Fi is the field with the phase added in there. And we're going to follow this with a shading interp. If we just say P color, we're going to have a bunch of black lines going through that. And since we have 1,024 lines, or actually 1,025 lines, it's just going to look black. We're going to get rid of the lines, and we're using interpolation to make it look smooth and continuous. We also want to scale it, so axis equal tight. But in addition to that, we also want to say off. The off ensures we don't have any of like the tick labeling and that sort of stuff. Everything's just off. All we see is the field. There's no text or other sorts of lines, because whatever appears there will get rendered in the movie and then imported into Blender. And most of the time, or almost all the time, I don't want those. If you did, well then by all means, don't put the off here. Let's run this and just see what it does. But in order to see the animation, we'll do a draw now. And let's go ahead and run this and see what happens. So it's using the P color. It's using the jet color map, but we can see that the field is moving. Now we want to use our color map, and our color map is binary. So this wave is going to look very flat when all is said and done, and only two colors. Color map, CM. Now let's see what that looks like. You can also check if we actually did get the green and blue that we're expecting. So there's the green and blue. And notice how flat that looks. And if I didn't mention that, you might look at this and say, oh, something doesn't seem right here. And well, this actually is correct. All right, that's looking really good. So remember, this one is only conveying color. The amplitude information will come from the second movie. So we have to put the draw now to force it to draw. At this point, we want to add a frame to the color movie because we've just drawn that. So add frame to color movie, or add frame to the movie that conveys colors. Maybe a better way to say that. But we're only going to do that if we enabled movie making. So if make movies, and then inside of that, the first thing we'll do is we will capture the image that we just drew. So we will say F equals get frame. Frame. Sorry, it's misspelled frame. Get frame. And then we have to tell it what to grab. Sometimes I'll do GCF. That's going to grab everything here, including the white. I tend to do that if I have multiple subplots here and I want to put them all in the same movie. If I just want the colored stuff here and not any of the white stuff, I would say GCA, get current axes. It gets a handle to the current axes and converts that. So there will be no white here. It's only going to grab what's green and blue. So F is an image. Yeah, we could actually save it as a bitmap or a PNG or whatever if we wanted to, but we're not going to do that. Instead, we're going to add it as a frame to our video. So we use the command write video. We tell it which video to save this to. So vid obj underscore color, because this is the color movie. And then what are we going to add? Well, the frame that we just grabbed, F. And that's it. If we ran this, and of course, if we turned on the movie making, which it's set to 0 right now, then we would see, we'd have this movie in memory. We need one more that conveys amplitude. Well, we already calculated the field. We don't have to do that. But since I don't like to type, I'm going to copy and paste that and just make edits at this point. So what we want to do now is draw field amplitude. We're drawing the same field, but we want to draw the absolute value of the real part. That way we don't have positive and negative, we only have all positive. Otherwise, shading interp, the axis equal tight off. The color map now, we don't want our our blue and green color map, we just want grayscale. And we'll use the grayscale color map, and the default is 256 colors, so I'll type that in. Not a problem at all. Okay, so now we have the field amplitude, and then the last step is add frame to the amplitude movie. So if make movies, we're going to get the new frame now. We're going to write the video, but now we're going to write it to the vidobj underscore amp. That is almost it. We have to run it to see if we've made any mistakes, but if we haven't made any mistakes, that's almost the entire code. The only thing is when this loop is done, we have to close the movies. So close movies. But we only want to close them if we're making the movies. So if make movies, and then inside here, we will close them. Close vidobj color, or not color, but col, just col. And I will copy and paste that, change the col to amp. That should be it. Let's run this without turning on movie making and watch what happens. And hopefully we didn't make any errors. If not, MATLAB is very polite to show us lots of red text that we've made some kind of goof. Okay, notice this is flashing back and forth. It's flashing between our flat color and our grayscale. And that's perfectly fine. It should look like this. So the blinking back and forth is what we expect to see because it's creating two different movies at the same time. If that's really bothering you, well, write the code so it creates one movie, closes that, and then starts the next movie. That way you see all the color and then all the grayscale. I chose to do it this way. We didn't turn on movie making, so we still have untested code here, but MATLAB's not giving us any red text. So far, everything seems okay. So we will turn on the movie making, cross our fingers, and hit run. Let's go. Now notice this is taking a little bit longer. That's because it's rendering a movie. So we'll let this go, and all should be done. Sometimes this is like watching paint dry. Luckily, it's only 50 frames. There are times where I render much longer movies, and I'll let this go and have lunch or something else. Also, for longer movies, I'll report what frame I'm rendering over in the command window, and I can keep track of where it is. But for 50 frames, not a problem waiting. We are 80-ish% done. It's not telling me that. I'm just looking at it and estimating that. And MATLAB didn't yell at us. It's just talking about padding. The MPEG-4, the MP4, it's a little bit picky about its number of pixels, and if something's a little bit off, MATLAB just goes ahead and adds those pixels for you. But I'm surprised. I didn't think 1024 was a problem. But that's it. We have now exported those two movies, and in the next video, we will import those into Blender. I hope this was helpful.